everybody, Mrs. White here. Today we're going to look at another trigonometric tool for finding missing sides and angles of triangles called the Law of Cosines. Before we get started, take a look at this triangle that you see on the page and ask yourself, what is anything that you know about the missing parts of this triangle? And if we did want to find the exact values of the angles in this triangle, what tools might you have that would help you find them? So consider pausing this video for a minute and thinking about that for yourself before you keep going. Okay, so let's take a closer look now. Unfortunately, we don't know a whole lot, although we do know something. We know that this 4 centimeters here is the smallest side of the triangle, which means that across from that, angle A here must be the smallest angle in the triangle. And we can use that same kind of reasoning. The 7 centimeters is the longest side of the triangle, so B must be the largest angle in the triangle. Unfortunately, it's not a right triangle, so we can't use trig ratios, sine, cosine, or tangent. And even worse, we can't use law of sines this time. Let's take a look at what would happen if you tried to use law of sines. When we did law of sines, we talked about how you need to have a match where, for example, if I know little a, which is the side across from angle A, I would need to know both of those. I'd have to know, for example, this side and the angle across from it. Look what happens when we don't have a match. In this triangle right here, we know all 3 sides, but we don't know any angles, so we have no matches. And if we tried to use law of sines, so for example, I could take sine of angle A and then set it up as a ratio over little a, which is the 4, and then sine of B over 7, I have 2 unknowns. I don't know A and I don't know B. So I can't solve this equation for either one. I just don't have enough information. There's too many unknowns. So law of sines is not going to work here. We need another tool. And this is where law of cosines comes in. The proof for law of cosines is a little bit more complicated than law of sines, and so I don't want to torture everyone with that. Let's just get straight to it. The law of cosines looks like this. It says for any triangle, and again, let's review here that when we talk about triangles, we'll use capital letters for the angles. So I'm using A, B, and C for the angles, and then lowercase letters for the side across from that angle, the corresponding side. So when we look at this formula right here, I actually wrote down 3 versions of essentially the same formula. Notice the only difference is which side you're starting with. So what this is essentially saying is that I can take any side in the triangle and square it, and that should be equal to the other 2 sides squared and added together. This almost looks like Pythagorean theorem, but keep in mind it's not a right triangle, so there must be something else going on in this formula. We're going to start off by squaring the other 2 sides and adding them together, but then we're going to subtract, double, the product of those same 2 sides we just squared and added together. Notice that same B and that same C, and also multiply that by the cosine of the angle that goes with whatever side we started with, that corresponds to that side. And so if I start with side B, I'll come over to the triangle over here. I would do B squared equals C squared plus A squared minus 2 times C times A times the cosine of B, because B is the angle that corresponds with the side I started with. So I tried to color code this down here for you. Notice that whatever side you start with, you're going to use that angle here at the very end. And whatever side you didn't start with then shows up on the other side and also shows up here in this big product. Notice this is all one big multiplication problem right here. 2 times B times C times the cosine of A. Okay, so this is the law of cosines. Before we get back to this problem from the beginning, this one's actually a little harder because it's an angle we're trying to find. Let's actually start with seeing how law of cosines plays out when it's a side that we want to find. And this is actually going to be a little bit easier than that warm-up problem. So taking a look right here, the only angle in this whole problem that I know is 92. And I do not yet know the side across from it, but I do know the other 2 sides. So if this is angle B that I know, I essentially want to start with the version of law of cosines that would start with little b, the side across from angle B. And so here's the setup right here. I'm going to start with this side and say B squared equals, and then I'll use the other 2 sides squared and added together, subtract, double those same other 2 sides, the 5 and the 6, times the cosine of 92. And again, the 92 corresponds with this b right here that was the side across from that 92. So here's law of cosines. Let's take a real close look at this equation we just set up. It actually turns out that the only unknown is on the left side, and everything else on this right side is just numbers. So you could actually just type this entire thing into something like a graphing calculator, and your calculator will output this 63.09. But let's look at how you would do it step by step, thinking about PEMDAS. So first I'm going to do a little simplifying. I'm going to take that 5 and that 6 and square it. 5 squared is 25, 6 squared is 36, and then I'm going to multiply all this together. I'm going to hold off on that cosine of 92 for now, just because that's going to be a decimal, and I'll just multiply these three numbers, 2 times 5 times 6, which would give me 60, and then that 1 minus sign is going to stay subtraction. So I've got minus 60 times the cosine of 92, and if I do 60 times the cosine of 92, I'll get roughly negative 2.09. That's a rounded approximation. Let's look a little closer here though. A few more things I can do to simplify. I can add the 25 and the 36, which gives me 61. One real common mistake with law of cosines is people really want to subtract this 61 and 60 right here, but keep in mind PEMDAS multiplication comes first, so we've got to avoid that temptation, and essentially you're just carrying down the 61, and now we've got 61, and it becomes minus a negative 2.09, which is 63.09. Again, you really could have typed that entire thing right there in your calculator and it would have given you that same 63.09. And now all we have to do at this point is square root both sides to undo the squaring, and we've got that b is roughly 7.94. So now I know that this side is 7.94. Now here's the good news. Now that I know that this is 7.94, I do have a match now. So you're never going to need to use law of cosines twice. It is a slightly more complicated looking formula, but you only ever need to use it once. Now we have a match, and so now we can finish finding the other angles in this problem by using law of sines. And so now that I have this match, I'm going to come over here and I can do sine of 92 over that 7.94 that we just found. And then I can choose the angle I feel like finding next. I just decided to choose A. Why not go alphabetical order? And so law of sines says I can set that equal to a sine ratio for another pair of angles and sides. And so I'm going to do sine of A over 6. So now I have this proportion here, and as we saw in the last lesson on law of sines, I can just cross multiply here. That gives me 7.94 times sine of A equals 6 times the sine of 92. Use division to undo the multiplication. We're essentially trying to isolate this sine A right here. That gives me sine A equals 0.7552. And now I can use inverse sine as a way of undoing that sine right there. And inverse sine will tell me what angle had this sine value of 0.7552. And now I know that angle A must be 49.04. So now I know the size of this angle right here. And I actually don't need any tools anymore. If I know two of the angles, I can always find the third angle by adding the two I know together and subtracting from 180, which is exactly what I did down here to find that angle C must be 38.96 degrees. Okay, so again, law of cosines may be a little more complicated at the beginning, but once you have that side or that angle, you have your match now, and you can now go do law of sines to find the missing information in the problem. Okay, again, for those of you interested in why this works, if you don't want to just trust this crazy looking formula, the notes that I'm providing do offer a proof for you. And so if you're interested, take a look at this, check in with me if you'd like to understand more deeply why law of cosines works. Okay, let's get back to that warm-up problem though. Okay, this is another problem where law of cosines is going to help us. So ignore this for now. We don't know that yet. In this warm-up problem, all we know are the three sides of the triangle. So I don't have a match yet, and I'm just going to pick one of the angles to find right away. And again, I just chose A. Again, why not alphabetical order? But your choice. You could choose B or C as your starting point. So I chose that A is the angle that I feel like finding first, which means that I want to start with little a, the 4 that's across from angle A. So when I come here to set up my law of cosines, I'm going to start with the 4 squared equals, Then I'll use the other two sides where I square them and add them together, minus 2 times those same other two sides times the cosine of A, where A is the angle that pairs or corresponds with that 4 that I started with. Now in this problem, I really do need to think about order of operations a little bit. I need to square that 4 to get 16. I'm going to square the 6, square the 7, and I'll even multiply the 2, the 6, and the 7 together right here to get 84. I can combine these two numbers, 36 plus 49, which is 85. But again, don't be tempted to do 85 minus 84 because multiplication, this 84 times cosine of A, has to happen first before this subtraction. So at this point right here where I have the arrow, it's actually completely simplified. There's no more simplifying to do, which means it's time to start solving. So I'm going to look at this 85 and say, well, that's a positive 85. I can undo that by subtracting 85. And now this negative 84 is actually multiplication in front of this cosine. So I'm going to divide by negative 84, and I get this decimal here. And now all I need to do is use inverse cosine to undo cosine, and I've got angle A. So now, just like in the last problem, now that we've found this 34.77, we have a match. So we don't need law of cosines again. Now we can use law of sines to finish this problem. And I can say sine of 34.77 over 4 equals, and then I just choose the angle I want to find next. I'm choosing B. So equals sine of B over 7. Now I have this proportion, which I can solve by cross multiplying. And then just use your undoing moves from there. Divide by 4. I will need inverse sine in this problem to get myself back to B. And I now have a second angle in this problem. I now know that B is 86.42. And just like always, when you know two angles in a triangle, we can always find the third angles by adding the two we know together and subtracting from 180 to find that third angle, leaving us with C equals 58.81. Thanks for listening.